The Maya tracked the stars with impossible precision. They built cities we are only now discovering. They developed mathematics that surpassed anything in Europe for 1,000 years. Someone did something extraordinary in those jungles. The question is who, and the answer may be more unsettling than either side wants to admit. But before we begin, do not forget to subscribe, and if you truly enjoy these videos, please leave a like. Let us begin. What if everything you thought you knew about ancient civilization was wrong? What if the jungles of Central America hide cities larger than London? What if a people who supposedly had no contact with the outside world built astronomical observatories more precise than anything Europe would create for another 1,000 years? What if their calendar predicted cosmic events we're only now beginning to understand? And what if, buried in the symbolism of their art, there are images that some believe show technology that should not exist? This is the story of the Maya, not the simplified version from your textbook, the real story. The one that archaeologists are rewriting right now, with lasers that see through jungle canopy. The one that challenges our assumptions about what ancient humans could achieve. The one that asks uncomfortable questions about where their knowledge came from. We will walk through cities that were lost for 1,000 years. We will decode calendars that track time across millions of years. We will examine the tomb of a king whose sarcophagus lid has sparked decades of debate about ancient contact with something beyond this world. And we will confront the latest discoveries that suggest the Maya civilization was far larger, far older, and far more mysterious than anyone imagined. The jungle is finally ready to share its secrets. Let us step inside. Chapter 1. The Jungle Speaks, Guatemala, the Piton region, 2018. A small aircraft cuts through humid air above an unbroken sea of green. Below, the jungle stretches to every horizon. Trees crowd together so tightly that the forest floor has not seen direct sunlight in centuries. Somewhere beneath that canopy, hidden by vegetation and time, lies one of the greatest archaeological discoveries of the 21st century. The plane carries no cameras in the traditional sense. Instead, it is equipped with LiDAR technology, light detection and ranging. The system fires laser pulses toward the ground at a rate of hundreds of thousands per second. Most of those pulses hit leaves, branches, the thick tangle of tropical growth, but some slip through, some find their way to the forest floor, and when they do, they reveal what the jungle has been hiding for over 1,000 years. The data comes back to researchers at the Pacunum Foundation, a Guatemalan organization dedicated to preserving cultural heritage. What appears on their screens stops them cold. Cities. Not small ceremonial centers, not isolated temple mounds. Cities. Vast urban networks with pyramids, palaces, roads, and agricultural systems stretching across the landscape. Defensive walls and fortifications suggest warfare on a scale never before attributed to the ancient Maya. Irrigation channels and terraced hillsides indicate intensive farming that could have supported millions of people. In a single survey, the LiDAR data revealed more than 60,000 previously unknown structures. 60,000, the number is almost impossible to process. Decades of ground-based archaeology in the region had identified perhaps a few thousand. Now, in weeks, that number multiplied by a factor of 20. The implications were staggering. The Maya lowlands, long thought to have supported a population of perhaps 1 to 2 million people at their peak, now appeared to have been home to 10 million or more. This was not a scattered collection of city-states separated by empty jungle. This was a continuous, interconnected civilization that had transformed the landscape on a scale comparable to ancient Egypt or Mesopotamia, and the world had missed it entirely. How does something this large stay hidden? The answer lies in the nature of the jungle itself. The Piton is not a forgiving environment. Annual rainfall exceeds 60 inches. Temperatures hover near 90 degrees Fahrenheit year-round. Vegetation grows with almost aggressive speed. A cleared field left untended will be reclaimed by forest within a decade. An abandoned city will vanish beneath the canopy within a century. The Spanish conquistadors who arrived in the 16th century found the Maya cities already swallowed by green. They built their missions and colonial towns on the coast and in the highlands, barely penetrating the dense interior. The jungle kept its secrets. For 500 years that secret held. Explorers occasionally stumbled upon ruins, John Lloyd Stephens and Frederick Catherwood famously documented sites like Copan and Palenque in the 1840s, their illustrated accounts igniting European fascination with Maya ruins. But even these intrepid travellers saw only fragments. They cleared vegetation from temple facades, sketched what they could see, and moved on. The full extent of Maya urbanism remained invisible. Traditional archaeology is slow, expensive, and physically brutal in jungle terrain. Researchers must hack through vegetation, contend with insects, snakes, and disease, and can only survey what they can physically reach. A team might spend an entire field season mapping a single plaza. The notion of surveying hundreds of square miles seemed impossible. LiDAR changed everything. The technology was originally developed for military and industrial applications. It found use in surveying terrain, measuring distances, and creating three-dimensional maps. Archaeologists began experimenting with airborne LiDAR in temperate environments, using it to find subtle features in European forests or to map medieval field systems beneath modern vegetation. But the Maya jungle represented the ultimate test. Could LiDAR penetrate tropical canopy dense enough to block 90% of sunlight? The answer, it turned out, was yes. The sheer volume of laser pulses meant that enough would slip through gaps in the leaves to build a detailed picture of the ground surface, and that picture was revolutionary. The 2018 survey covered more than 800 square miles of the Piton. It revealed not only individual structures but entire systems of infrastructure. Roads connected major centres, some of them raised causeways built to stay above seasonal flooding. Reservoirs collected rainwater for the dry season. Defensive walls protected urban cores. Agricultural terraces climbed hillsides that appeared, from the air, to be virgin forest. Most striking was the evidence of interconnection. The Maya lowlands had long been understood as a patchwork of competing city-states, each ruled by a divine king, frequently at war with neighbours but fundamentally independent. The LiDAR data suggested something more complex. The infrastructure implied coordination. The defensive systems implied threat perception across vast areas. The agricultural intensity implied central planning. This was not a collection of villages that happened to share a culture. This was a civilization with the organizational capacity to reshape its environment on a continental scale. The discovery forced archaeologists to reconsider everything they thought they knew. Population estimates had to be revised upward, dramatically. The Maya collapse, that mysterious abandonment of the lowland cities around the 9th century, became even harder to explain. How do 10 million people vanish? Where do they go, and why? The LiDAR findings also reopened questions about Maya origins. If the lowland civilization was this large and this sophisticated, how did it begin? What were the first Maya cities? How old were they? And what allowed a Stone Age people, lacking metal tools, draft animals, or the wheel, to build something that rivaled the great civilizations of the Old World? Some of those questions have conventional archaeological answers. Others venture into territory that mainstream science considers speculative at best. But the LiDAR data had made one thing clear. The Maya were not a minor New World curiosity. They were one of humanity's great civilizations, and we are only beginning to understand what they achieved. To grasp the scale of Maya accomplishment, we need to go back. Not to the classic period that most people think of when they hear the word Maya, not to the famous cities of Tikal and Palenque that flourished between the 4th and 9th centuries. We need to go earlier, much earlier, to a time when Rome was a village of mud huts on the Tiber, when the Parthenon was still centuries in the future, when the Great Wall of China had not been imagined. We need to go to El Mirador. El Mirador sits deep in the Guatemalan jungle near the border with Mexico. Reaching it requires either a helicopter flight or a 5-day trek through some of the most challenging terrain in the Americas. There are no roads, there is no infrastructure, just jungle and ruins, and those ruins are immense. The central complex of El Mirador includes the La Danta Pyramid, which rises 230 feet above the forest floor. By volume, it is one of the largest pyramids ever constructed anywhere on Earth. Its base covers an area comparable to the Great Pyramid of Giza. Its mass exceeds that of most ancient structures outside of Egypt. But here is what makes El Mirador genuinely shocking. It was built around 600 BCE. The classic Maya period would not begin for another 1,000 years. The famous cities that tourists visit today, Tikal and Chichen Itza and Uxmal, all came later. El Mirador was the capital of a preclassic civilization that mainstream archaeology barely acknowledged until recently. The site was first identified in the 1920s, but its size and significance were not recognized for decades. The jungle was too thick, the location too remote. Early surveys underestimated the scale of the ruins. It was not until sustained excavations began in the 1970s, and especially after LiDAR surveys in the 2000s, that El Mirador revealed its true nature. The city was not alone. LiDAR and ground surveys have identified dozens of preclassic centers in the Mirador Basin, connected by raised causeways that allowed travel during the rainy season when the lowlands flooded. This was an organized state, or perhaps a network of allied states, operating at a level of complexity previously thought impossible for the Americas at that time. The architecture at El Mirador shows sophisticated engineering. The pyramids were not simple piles of rubble faced with stone. They were carefully designed structures with internal drainage systems, precisely cut limestone blocks, and elaborate sculptural programs. The facades featured massive stucco masks depicting deities and supernatural beings, some of them 2 stories tall. These are not the products of a simple society. They required organized labor on a massive scale. They required architects and engineers capable of planning structures that would take generations to complete. They required surplus food production to free workers from agriculture. They required political authority capable of commanding that labor and maintaining it over decades or centuries. How did the Maya achieve this, and where did the knowledge come from? Conventional archaeology offers a developmental narrative. The Maya emerged from earlier Mesoamerican cultures, gradually developing more complex societies through a process of agricultural intensification, population growth, and social stratification. Writing, astronomy, mathematics, and monumental architecture all evolved over time, building on earlier traditions, but there are puzzles. The pre-classic Maya seem to appear with remarkable sophistication already in place. The earliest known Maya writing dates to the 3rd century BCE, and it is already a complex script capable of recording historical events, astronomical observations, and religious texts. Where are the simpler precursors? Where is the developmental sequence that leads to this level of achievement? The same question applies to Maya, astronomy, and mathematics. By the Classic period, the Maya were tracking the cycles of Venus with an error of less than 2 hours over 5 centuries. They had calculated the length of the solar year with greater accuracy than the European calendars of the same era. They used a positional notation system with the concept of zero, a mathematical innovation that Europe would not adopt until the Middle Ages. Did the Maya invent all of this independently? Did they inherit it from earlier Mesoamerican cultures like the Olmec? Or is there another explanation, one that conventional science is reluctant to consider? These questions hover at the edge of Maya studies. Most professional archaeologists dismiss them as pseudoscience, products of cultural arrogance that refuses to accept that indigenous peoples could achieve great things without outside help. And there is merit to that criticism. The ancient astronaut hypothesis has often served as a vehicle for racism, denying credit to non-European civilizations by attributing their accomplishments to extraterrestrial intervention. But the questions persist, not because the evidence for ancient contact is strong, but because the Maya remain genuinely mysterious. Their origins are murky, their achievements are extraordinary, and their own mythology is filled with references to beings from the sky, to ancestors who came from the stars, to knowledge that was given rather than discovered. We will explore those mythologies later. We will examine the controversial imagery that has fueled decades of speculation. We will ask whether there is any legitimate evidence for contact with non-human intelligence, or whether the Maya story is fully explicable in human terms. But first, we need to understand what the Maya actually accomplished. The cities, the calendars, the astronomical knowledge, the mathematical systems. Only by grasping the scale of their achievements can we meaningfully ask where those achievements came from. The jungle has revealed its cities. Now we must understand what those cities meant. In the next chapter, we will travel to the great preclassic centers, to the origins of Maya civilization, to the moment when something extraordinary emerged from the forests of Central America, something that would track the stars across millennia, something that would build pyramids to rival Egypt, something that would vanish almost completely, leaving only stone and mystery behind. The Maya did not simply live in the jungle. They conquered it. They reshaped it. They made it their own. And then, for reasons we are still struggling to understand, they walked away. The question is why, and the answer may be more unsettling than we expect. Chapter 2. Cities older than Rome. The year is 600 BCE. In Italy, Rome is a cluster of villages on 7 hills, ruled by Etruscan kings and centuries away from becoming an empire. In Greece, the city-states are beginning their rise, but the Parthenon will not be built for another 150 years. In China, the Zhou dynasty is fragmenting, and the great philosophies of Confucius and Laozi are just emerging. In India, the Buddha is perhaps a young man, or perhaps not yet born, and in the jungles of Central America the Maya are building pyramids, not small ceremonial mounds, not simple earth platforms, pyramids, massive structures of limestone and rubble, faced with carved stone and painted stucco, rising above the jungle canopy like mountains made by human hands. At El Mirador, the La Danta complex reaches a height of 230 feet. At nearby Calakmul, pyramids pierce the sky. At Nakbe, the oldest known monumental Maya architecture dates to the 8th century BCE or earlier. These are not the famous cities. Tourists do not visit El Mirador. There are no hotels, no buses, no gift shops selling replica calendars. The pre-classic Maya remain largely unknown to the public, overshadowed by the classic period cities that came later. But the pre-classic was the foundation. Everything the Maya would become, everything that made them one of humanity's great civilizations, began here, in these jungle cities that predate Rome. To understand what the Maya accomplished, we need to understand what they were working with, and what they were working with was almost nothing. The Maya lowlands are not a hospitable environment for civilization. The soil is thin and quickly exhausted. There are no navigable rivers to speak of, no natural harbours, no easy routes for transportation. There are no metal deposits. The Maya would work copper and gold in later centuries, but only through trade with distant regions. In their heartland, they were a Stone Age people in the strictest sense. Their tools were made of stone, bone, and wood. They had no draft animals. The Americas lacked horses, oxen, and donkeys. Everything that needed to be moved was carried by human muscle. Every stone that went into those pyramids was cut, shaped, and placed by hand. Every load of plaster was mixed and carried in baskets. The logistics were staggering. They did not use the wheel for transportation. The wheel was known in Mesoamerica. We have found wheeled toys, but it was never applied to carts or wagons. Without draft animals, wheeled vehicles would have been of limited use anyway. Everything moved on human backs, along footpaths cut through the jungle. And yet, they built cities, they built pyramids, they developed writing, mathematics, and astronomy to levels that rivaled or exceeded the old world. They created a calendar system of extraordinary sophistication. They tracked the movements of Venus, Mars, and the Moon with precision that would not be matched in Europe for 1,000 years. How? Conventional archaeology offers several explanations. The first is agriculture. The Maya developed intensive farming techniques that could support large, dense populations. They drained swamps and created raised fields for cultivation. They built terraces on hillsides to prevent erosion. They managed forests, encouraging useful species and suppressing competitors. They practiced a form of agroforestry that modern environmentalists are only beginning to appreciate. The LiDAR surveys revealed the scale of this agricultural transformation. What had appeared to be virgin jungle was actually secondary growth covering ancient field systems. The Maya had reshaped vast areas of the lowlands for food production. Canals channeled water, reservoirs stored it for the dry season. The landscape was engineered. This agricultural productivity freed labour for other tasks. If you can produce enough food with 80% of your population, the other 20% can become builders, priests, artisans, administrators. Specialization becomes possible. Cities become possible. The second explanation is social organization. The Maya developed hierarchical societies ruled by divine kings who claimed descent from gods and ancestors. These kings commanded labor tribute from commoners. They organized the construction projects, the agricultural works, the military campaigns. They created the political structures that made coordination possible. Maya inscriptions from the classic period give us detailed records of royal dynasties, warfare, and ritual. The kings were called Kuhulajau, divine lords. They were intermediaries between the human world and the supernatural. Their blood was sacred. Their power was absolute. But how far back does this system go? The inscriptions come from the Classic period, from the 4th century onward. The pre-classic cities are older than the inscriptions. We must infer their political organisation from architecture and archaeology. The presence of massive pyramids suggests powerful rulers who could command labour. The standardisation of architectural styles across different sites suggests some form of integration. But the details remain murky. The third explanation is trade. The Maya were connected to wider Mesoamerican exchange networks from an early date. Obsidian, a volcanic glass used for cutting tools, came from highland Guatemala, hundreds of miles from the lowland cities. Jade, the most precious material in Mesoamerican culture, came from the Motagua Valley. Cacao, the source of chocolate and a form of currency, grew in specific ecological zones and was traded widely. These trade networks connected the Maya to other cultures. The Olmec civilization, which flourished along the Gulf Coast from about 1500 to 400 BCE, may have influenced Maya development. Olmec art features many motifs that would later appear in Maya iconography. Olmec sites show evidence of sophisticated ritual practice, and possibly early writing. Some researchers believe the Maya inherited key cultural elements from the Olmec. Others argue for independent development. The debate continues, but the trade networks are undeniable. The Maya were not isolated. They were part of a Mesoamerican world. These explanations are powerful. They account for much of what we observe. Agriculture plus social organization plus trade equals civilization. The formula works. But there are still puzzles. The speed of Maya development is striking. The earliest Maya villages date to around 1900 BCE. By 600 BCE, the Maya were building some of the largest structures in the ancient Americas. That is a span of roughly 1300 years. In comparative terms, that is fast. Egyptian civilization took much longer to reach monumental scale. Mesopotamian development was similarly gradual. The Maya seem to have taken a shortcut. Not in a supernatural sense necessarily. Perhaps they were building on earlier developments that we have not yet discovered. Perhaps the Olmec influence was more significant than currently recognized. Perhaps there are foundational sites still hidden under the jungle, or perhaps, as some alternative researchers suggest, the Maya received assistance, knowledge transferred from an unknown source, technology, or at least concepts that accelerated their development. This is the ancient astronaut hypothesis, and we will examine it in detail later. For now, let us note that the speed of Maya development is unusual and requires explanation. Another puzzle is the astronomical knowledge. By the Classic period, the Maya had calculated the length of the solar year as 365.2420 days. The modern value is 365.2422 days. The Maya were accurate to within about 30 seconds per year. How did they achieve this? Not with telescopes, not with precision instruments. With the naked eye, counting days, watching the sun rise and set against stone markers, generation after generation. The same precision applied to other cycles. The Maya tracked the synodic period of Venus, the time between successive appearances as the morning star, with an error of less than 2 hours over 584 days. They knew the cycles of Mars. They predicted eclipses. This knowledge was not decorative. It was integrated into Maya religion, politics, and warfare. Kings timed their actions to astronomical events. Temples were oriented to celestial alignments. The calendar was the organizing principle of Maya life. Where did this astronomical tradition originate? The pre-classic Maya clearly had some form of astronomical practice. The alignment of buildings at El Mirador and other early sites suggests celestial observation. But the full flowering of Maya astronomy appears in the Classic period, when we have written records and detailed calculations. Did the Maya develop this knowledge independently? Did they inherit it from the Olmec or some other predecessor culture? Or is there another source, one that conventional archaeology does not acknowledge? Let us set that question aside for now, and focus on what we can see. The pre-classic cities. El Mirador is the largest, but it is not alone. The Mirador Basin, a roughly 40 by 25 mile area in northern Guatemala, contains dozens of pre-classic centers connected by raised causeways called sac biob. These causeways were engineering achievements in themselves. Built of limestone rubble with plastered surfaces, they stretched for miles through swampy terrain, allowing travel during the rainy season when lower ground flooded. The Sac-Biob connected El Mirador to Nakbe, one of the oldest known Maya cities. Nakbe shows monumental architecture dating to the 8th century BCE. Platforms, plazas, and pyramids appear in a recognizable Maya style. Stone masks depicting deities adorn the building facades. This is not a primitive village. This is a city, or something approaching a city, centuries before the pre-classic fluorescence at El Mirador. What was happening at Nakbe in the 8th century BCE? We do not fully know. The site has been excavated, but the earliest levels are difficult to reach and interpret. What we can say is that Maya urbanism did not spring fully formed from nothing. There was a developmental sequence. Nakbe and sites like it represent an early phase, followed by the massive construction projects of El Mirador and its peers. The El Mirador fluorescence lasted roughly from the 6th century BCE to the 2nd century CE. During this period, the city was one of the largest urban centers in the ancient Americas. Population estimates are difficult, but researchers suggest that the greater El Mirador area may have supported several 100,000 people at its peak, and then it ended. Sometime around the 2nd century CE, El Mirador was largely abandoned. The Great Pyramids fell silent, the causeways grew over, the jungle began its slow reclamation. By the time the Classic period began, around the 4th century, El Mirador was a ruin. Other cities, Tikal, Calakmul, Palenque, would rise in its place. Why did El Mirador fall? This is one of the great mysteries of Maya archaeology. Various theories have been proposed. Environmental degradation is one. The intensive agriculture that supported the city may have exhausted the soil. Deforestation for construction and lime plaster production may have triggered erosion and altered local climate. Political collapse is another possibility. Perhaps El Mirador was defeated by rivals. Perhaps internal conflict tore the society apart. Perhaps the ruling dynasty lost legitimacy. We have no inscriptions from this period, so we cannot read the political history directly. Climate change may have played a role. Paleoclimate studies suggest that the Maya lowlands experienced periodic droughts. A severe drought at the wrong moment could have destabilized a society dependent on regular rainfall for agriculture and drinking water. Some alternative researchers see the abandonment of El Mirador as evidence of a more dramatic event, a catastrophe of some kind, a departure rather than a collapse. The Maya, they suggest, were not simply fleeing environmental problems or political chaos, they were leaving for reasons we do not yet understand. This interpretation is speculative. Mainstream archaeology does not support it. But the mystery remains. El Mirador was one of the greatest cities of the ancient world. It was abandoned. The jungle swallowed it, and for 2,000 years it remained hidden. The pattern would repeat. The classic Maya cities that rose after El Mirador would also be abandoned. The 9th century collapse would empty the lowlands of their urban populations. The jungle would reclaim those cities too. Something about Maya civilization seems inherently unstable. Great fluorescence followed by sudden decline. Construction followed by abandonment. Complexity followed by simplification. Is this a failure of the Maya system, or is it something else? A choice, perhaps? A cycle? A pattern that we, with our linear assumptions about progress, cannot easily comprehend? The Maya viewed time differently. Their calendar was not a simple count from a starting point to an indefinite future. It was cyclical. Periods began and ended. Ages came and went. Creation itself was not a unique event, but something that had happened before and would happen again. Perhaps the Maya built their cities knowing they would be abandoned. Perhaps the cycle of construction and decline was not failure but fulfillment. Perhaps the jungle was always meant to return. These are philosophical questions, not scientific ones. But they hover over Maya studies like the mist that rises from the forest at dawn. We look at the ruins and see tragedy. The Maya may have seen completion. Let us return to the concrete. The pre-classic cities tell us that Maya civilization was far older and far more sophisticated than earlier scholars realized. The foundations were laid not in the classic period, but centuries before, in the swamps and jungles of the Mirador Basin. The architecture of these early cities shows sophisticated engineering. The massive pyramids were not solid piles of rubble. They had internal structures, drainage systems, and carefully planned approaches. The facades were covered with painted stucco, featuring elaborate iconographic programs that depicted gods, supernatural creatures, and cosmic themes. The stucco masks at El Mirador are particularly impressive. Some are 2 stories tall. They show the faces of deities, often with elaborate headdresses and symbolic elements. These were not simple decorations. They were statements about the nature of the cosmos and the place of the city within it. Creating these masks required artistic skill, but also organizational capacity. The stucco had to be mixed and applied while still wet. Teams of artists and labourers had to work in coordination. The designs had to be planned in advance. This was not folk art. This was institutional art produced by specialists working within an organised cultural framework. The same sophistication appears in the urban planning. The pre-classic cities were not random agglomerations. They had oriented plazas, standardised building types, and consistent relationships between structures. The central precincts were distinct from residential areas. Causeways connected major buildings. This level of planning implies central authority. Someone was making decisions about where buildings would go, how resources would be allocated, what the city would look like. That someone was almost certainly a king, or a group of elites functioning as a ruling class. The pre-classic Maya had all the elements of complex civilization: urbanism, monumental architecture, artistic sophistication, trade networks, social hierarchy, agricultural intensification. They lacked only one thing that later periods would provide: writing. Or did they? The earliest securely dated Maya inscriptions come from the 3rd century BCE, but there are tantalizing hints of earlier writing. Some researchers believe that the pre-classic Maya had a script that has not survived, or that has not yet been recognized. The standardization of iconography suggests a symbolic system that may have been ancestral to later hieroglyphic writing. The question matters because writing is often seen as a marker of full civilization. If the pre-classic Maya had writing, they were even more sophisticated than currently recognized. If they did not, then the development of Maya script becomes a phenomenon of the late pre-classic and classic periods, something that emerged after the first great cities were already built. Either way, the pre-classic Maya were remarkable. They created a civilization in one of the least hospitable environments on Earth. They built monuments that still inspire awe after 2,000 years, and they did it without metal, without wheels, without draft animals, and without any of the advantages that old world civilizations enjoyed. How did they know what to build? How did they organize the labor? How did they develop the techniques? The conventional answer is that they figured it out. Human beings are intelligent and adaptable. Given enough time and population, complex societies emerge. The Maya had time and population. They had cultural traditions inherited from earlier peoples. They had trade connections that brought ideas and materials. They had everything they needed. The unconventional answer is that they had help. Not divine help in the religious sense, not supernatural intervention, something else. Something that provided knowledge or technology or guidance, something that accelerated what should have been a slower process. We will explore that possibility in later chapters. We will look at the iconography that has fueled decades of speculation. We will examine the claims of ancient astronaut theorists and the responses of mainstream archaeologists. We will try to separate evidence from fantasy, but for now, let us acknowledge the mystery. The pre-classic Maya appeared, built cities that rivaled anything in the ancient world, and then vanished. Their successors in the classic period would build on their foundations but never fully match their scale. El Mirador remained the largest Maya site ever built. Something happened in those early centuries, something that created a civilization of extraordinary sophistication. Understanding what that something was may be the key to understanding the Maya as a whole. The jungle has spoken. It has revealed cities older than Rome. Now we must listen to what those cities are trying to tell us. In the next chapter, we turn from stone to sky. The Maya were not only builders, they were astronomers of the highest order. Their knowledge of celestial cycles was uncanny. Their calendar tracked time across millions of years. And their observations of the heavens raise questions that conventional science struggles to answer. The mathematics of the stars awaits. Chapter 3. The Mathematics of the Stars. The Dresden Codex sits in a climate-controlled vault in the Saxon State Library in Germany. It is a folding screen book made of fig bark paper, coated with lime plaster and covered with painted glyphs and images. It measures roughly 3.5 meters when fully extended. It dates to the 11th or 12th century CE, though it is almost certainly a copy of much older originals. It is one of only 4 Maya books to survive the Spanish conquest. The rest were burned. Diego de Landa, the Franciscan bishop of Yucatan, wrote in 1562 that he ordered the destruction of Maya books because they contained nothing but superstition and lies of the devil. In a single bonfire at Mani, he destroyed 27 hieroglyphic scrolls, 197 vessels, 5,000 idols, and an unknown number of other documents. We will never know what was lost, an entire civilization's written heritage reduced to ash in an afternoon. What survives, including the Dresden Codex, is a fragment of a fragment. But what a fragment! The Dresden Codex contains astronomical tables of stunning precision. It tracks the cycles of Venus across centuries. It predicts eclipses. It correlates multiple calendrical systems in ways that reveal a mathematical sophistication we're only beginning to appreciate. And it raises questions. Questions about how the Maya knew what they knew. Questions about where their astronomical knowledge came from. Questions that mainstream archaeology answers confidently, but that continue to trouble careful observers. Let us begin with what the Maya actually achieved. The Maya calendar is often discussed as if it were a single system. It was not. It was an interlocking set of cycles, each serving different purposes, all of them geared together like the wheels of a cosmic machine. The most basic cycle was the kin, the day. Days were the fundamental unit of Maya timekeeping. From days, everything else was built. The first major cycle was the Tzolk'in, a 260-day sacred calendar. The Tzolk'in combined 20 named days with 13 numbers, producing a cycle of 260 unique day names. This calendar was used for divination, for determining auspicious days, for ritual scheduling. It was not astronomical in the sense of tracking solar or lunar phenomena. It was cultural, embedded in Maya religion and daily life. The second major cycle was the Harb, a 365-day civil calendar. The Harb consisted of 18 months of 20 days each, plus a 5-day period at the end called Wyeb. The Harb approximated the solar year and was used for agricultural and administrative purposes. The Tzolk'in and Harb interlocked to create the calendar round, a cycle of approximately 52 years. Any combination of Tzolk'in and Harb dates would repeat after 18,980 days, or roughly 52 solar years. The calendar round was the basic framework for dating events in Maya life, but the Maya needed to track longer periods. For historical records, for astronomical calculations, for cosmological speculation, the calendar round was not enough. They needed a count that could extend indefinitely into the past and future. They created the long count. The long count was a cumulative count of days from a fixed starting point. That starting point in our calendar corresponds to August 11th, 3114 BCE. Why that date was chosen is uncertain. It may relate to mythological events, to astronomical cycles, or to calendrical calculations that we do not fully understand. The long count used a vigesimal system, base 20, with one modification. The basic units were kin, days, winal, 20 days, tun, 360 days, katun, 7,200 days, or roughly 20 years, and baktun, 144,000 days, or roughly 394 years. A typical long count date was written as 5 numbers separated by dots. For example, 9.15.10.0.0. This indicated 9 baktuns, 15 katuns, 10 tons, 0 winals, and 0 kin since the starting point. The date could be calculated precisely and compared with other dates across centuries. The long count allowed the Maya to think about time on scales that dwarf human history. The current cycle, the one that began in 3114 BCE, was scheduled to complete on December 21st, 2012 CE. This was the famous Maya apocalypse date that generated so much popular attention. The Maya did not actually predict apocalypse. They predicted the completion of a cycle and the beginning of a new one. Just as our calendar rolls over from December 31st to January 1st without the world ending, the Maya long count rolled over from 12.19. 19.17.19 to 13.0.0.0.0. A new Baktun began. Life continued. But the precision of the long count is impressive. The Maya were tracking time across more than 5,000 years with day-level accuracy. They were maintaining calendrical records that allowed comparison of events separated by centuries. They were thinking about time in ways that few ancient cultures matched. And they were doing more than just counting days. They were predicting astronomical events. The Dresden Codex contains a Venus table that tracks the synodic period of Venus across centuries. The synodic period is the time between successive appearances of Venus as the morning star as seen from Earth. The modern value is 583.92 days. The Maya calculated it as 584 days, an error of less than 2 hours over the entire cycle. This accuracy is remarkable. Venus is visible to the naked eye, but its movements are complex. It appears as the morning star for about 260 days, then disappears behind the sun, then reappears as the evening star for another 260 days, then disappears again before returning as the morning star. Tracking this cycle required patient observation over many years. The Maya did more than observe, they predicted. The Venus table in the Dresden Codex covers 365 Venus cycles, roughly 481 years. It includes correction factors to account for the small difference between 584 days and the true synodic period. The Maya understood that their idealized cycle drifted slightly from reality and built in mechanisms to compensate. Why did the Maya care so much about Venus? Venus was not just a point of light in the sky. Venus was Kukulkan, the feathered serpent, one of the most important deities in the Mesoamerican pantheon. The movements of Venus had religious and political significance. Wars were timed to Venus events. Kings claimed association with the planet. The appearance and disappearance of Venus was woven into Maya mythology. But there was also a practical dimension. If you can predict Venus, you can predict eclipses. The Dresden Codex contains an eclipse table that covers 33 years of lunar eclipses. The table identifies potential eclipse dates and provides correction factors for observational uncertainty. Eclipse prediction is difficult. It requires understanding the interplay of solar and lunar cycles, the nodes where the moon's orbit crosses the ecliptic, and the geometry of shadow and light. The Maya could not have developed these tables without sophisticated mathematical thinking, and that thinking was based on a number system more advanced than anything Europe had at the time. The Maya used a positional number system with base 20. Unlike Roman numerals, which are additive and awkward for calculation, Maya numerals allowed complex arithmetic. More importantly, the Maya had the concept of zero. Zero seems simple to us. It is the placeholder, the nothing, the empty set. But zero was not obvious to ancient mathematicians. The Greeks never fully developed it. The Romans did not have it. The concept of zero as a number in its own right, not just an absence, was one of humanity's great intellectual achievements. The Maya had zero by at least the 4th century BCE. They represented it with a shell glyph, an elegant symbol for emptiness. With zero, their positional system became fully functional. Numbers of any size could be written compactly and manipulated arithmetically. This mathematical sophistication enabled the astronomical calculations. Without positional notation, tracking Venus cycles over centuries would have been impossibly cumbersome. With it, the Maya could build tables, identify patterns, and make predictions that would hold for generations. Where did this knowledge come from? The conventional answer is that it developed internally. The Maya inherited some mathematical and astronomical traditions from earlier Mesoamerican cultures, particularly the Olmec. They refined and extended these traditions over centuries of observation and calculation. The precision we see in the Dresden Codex is the result of generations of skywatchers, patiently recording, comparing, and correcting. This explanation is plausible. Human beings are capable of remarkable intellectual achievements when motivated. The Maya had motivation. Their religion demanded astronomical knowledge. Their politics incorporated celestial events. Their agriculture depended on seasonal cycles. They had every reason to develop sophisticated astronomy, but there are puzzles. The speed of development again is striking. The Maya seem to have jumped from simple skywatching to precision astronomy in a relatively short time. Where are the intermediate stages? Where are the tables with larger errors? The systems that did not quite work? The trial and error that should precede mastery? The connection between observation and calculation is mysterious. Naked eye observation can tell you when Venus rises and sets. But calculating the synodic period to 5 decimal places requires more than observation. It requires mathematics. Where did the Maya learn to do that kind of calculation? The correlation with other knowledge systems is intriguing. Maya astronomy was not isolated. It was connected to architecture, to writing, to ritual, to everything. The integration is so complete that it appears almost designed, as if someone laid out a master plan and the Maya implemented it. These are not proofs of outside influence. They are observations that invite explanation. Conventional archaeology explains them in conventional ways. Alternative researchers see them as clues pointing towards something else. Let us consider one specific claim. The Temple of Kukulkan at Chichen Itza, known as El Castillo, is one of the most famous Maya structures. It is a stepped pyramid roughly 75 feet tall, with staircases on all four sides leading to a temple at the summit. Each staircase has 91 steps. 4 staircases times 91 steps equals 364. Add the platform at the top, and you get 365, the number of days in the solar year. The pyramid is astronomically aligned. During the spring and fall equinoxes, the afternoon sun casts a shadow on the northwest balustrade that creates the illusion of a serpent descending the staircase. The serpent's head, carved in stone at the base of the stairs, seems to come alive as the shadow joins it. Thousands of tourists gather each equinox to watch this effect. Is this intentional? Was El Castillo designed to produce this phenomenon? Most archaeologists believe yes. The alignment is too precise to be accidental. The Maya knew what they were doing. They built a calendar in stone, a temple, that marked the turning points of the year with light and shadow. The question is how? How did the Maya calculate the angles? How did they know where to place the building? How to orient the stairs? How to carve the serpent head so that the shadow would align precisely? Modern architects with computers and surveying equipment would find this challenging. The Maya did it with observation, geometry, and trial and error. Or so the conventional explanation goes. Alternative researchers ask whether trial and error is really sufficient. Building a pyramid takes years or decades. You cannot try different alignments and see which works. You have to get it right the first time. That requires knowledge, not experimentation. Where did that knowledge come from? Some researchers point to the consistency across Maya sites. Astronomical alignments appear not just at Chichen Itza, but at Uxmal, Palenque, Copan, and dozens of other cities. The orientations vary, tracking different celestial events, but the precision is similar. This suggests a shared body of knowledge, a tradition that was transmitted from generation to generation. That tradition must have originated somewhere. The Maya did not invent astronomy independently in each city. They learned it from someone or something. The question is who or what. The conventional answer is cultural transmission. Earlier Mesoamerican cultures, particularly the Olmec, developed astronomical practices that the Maya inherited and extended. The knowledge spread through trade, migration, and cultural contact. No outside influence is required. The alternative answer is that the Maya received their astronomical knowledge from a non-human source. Ancient astronauts, extraterrestrial visitors, a lost advanced civilization. Someone who possessed knowledge that should not have existed at that time and place. This is an extraordinary claim. It requires extraordinary evidence. Does such evidence exist? The ancient astronaut theorists point to several sources. Maya mythology describes gods who came from the sky. The Popol Vuh, the Quiche Maya creation myth, tells of beings who created humanity and taught them the arts of civilization. Could these myths preserve memories of actual contact with advanced beings? Maya iconography includes images that seem anomalous. The sarcophagus lid of Pakal the Great at Palenque shows a figure surrounded by complex machinery or technology. To some observers, Pakal appears to be operating a spacecraft. We will examine this claim in detail in the next chapter. Maya astronomical knowledge is more precise than seems possible for naked eye observation. The Dresden Codex calculations imply mathematical sophistication that exceeds what we would expect from a Stone Age culture. Could this knowledge have been given rather than discovered? These arguments are not conclusive. Mainstream archaeology rejects them firmly. The myths are metaphorical, not historical. The iconography follows. Maya artistic conventions, not depictions of technology. The astronomical precision is explained by patient observation over centuries. Both sides have points. Neither has definitive proof. What we can say with confidence is that Maya astronomy was extraordinary. The precision of their calculations, the sophistication of their calendar, the integration of celestial observation into every aspect of their culture, all of this sets them apart from most ancient civilizations. The Maya were watching the stars. They were counting the days. They were tracking Venus and predicting eclipses. They were building pyramids aligned to equinoxes and solstices. They were doing things that required knowledge, coordination, and purpose. Whether that knowledge came from within or from beyond, the achievement stands. The Maya understood the cosmos in ways that we are only beginning to recover. The Dresden Codex is a survivor. One book out of thousands, one fragment of a shattered tradition. What it preserves is precious. What was lost, we can only imagine. The Spanish burned the books. They believed they were destroying superstition and devil worship. They were destroying a library, a body of knowledge accumulated over centuries, calculations that track the heavens across millennia. We will never fully know what the Maya knew. We have pieces, we have hints, we have ruins and carvings and a handful of surviving texts, but the stars are still there. The cycles still turn. The long count has rolled over into a new Baktun. Time continues as the Maya understood it would. In the next chapter, we descend from the sky to the earth. We enter a tomb, the tomb of a king whose sarcophagus lid has sparked decades of controversy. The tomb of Pakal the Great at Palenque. Is it a portrait of a Maya ruler in the underworld, or is it something else entirely? The astronaut question awaits. Chapter 4. Pakal and the Astronaut Question, June 15th, 1952. The Mexican, archaeologist Alberto Rusluilier stands at the base of a hidden stairway inside the Temple of the Inscriptions at Palenque. For 4 years, his team has been excavating this passage, removing rubble fill that the ancient Maya deliberately placed to seal what lies below. The stairway descends roughly 80 feet into the pyramid's core. At the bottom, a triangular doorway opens into a vaulted chamber. Ruz enters. The air is heavy, ancient, undisturbed for over 1,000 years. What he sees takes his breath away. The chamber is roughly 30 feet long and 13 feet wide. The walls are decorated with stucco reliefs showing 9 figures, probably lords of the underworld. But the centerpiece is a massive stone sarcophagus, roughly 12 feet long and 7 feet wide, covered by an elaborately carved lid weighing several tons. Ruz has found the tomb of Pakal the Great, one of the most powerful kings in Maya history. Kinich Janab Pakal ruled Palenque from 615 to 683 CE, a reign of 68 years. Under his leadership, Palenque became one of the most important cities in the Maya world. The Temple of the Inscriptions, built as his funerary monument, contains one of the longest hieroglyphic texts known from ancient Mesoamerica. Pakal was buried with jade ornaments, a jade mosaic mask covering his face, and offerings of obsidian, shell, and pottery. His skeleton showed he lived to an advanced age, perhaps 80 years old, with significant arthritis and dental wear consistent with the strains of a long life. But it is not the burial that has captured the world's imagination. It is the sarcophagus lid. The lid is a single slab of limestone, roughly 12 feet by 7 feet, carved with an intricate scene. At the center is a human figure, reclining, surrounded by complex imagery. Above him rises what appears to be a cross or tree. Below him opens a skeletal jaw, perhaps representing the entrance to the underworld. Around the edges are astronomical symbols and hieroglyphic texts. The conventional interpretation is clear. The figure is Pakal, shown at the moment of death, descending into Xibalba, the Maya underworld. The tree above him is the world tree, the axis mundi that connects the realms of the living and the dead. The skeletal jaw below is the earth monster, swallowing the king as he passes from life to death. The imagery is consistent with Maya cosmology as we understand it from other sources. The world tree appears throughout Maya art. The underworld journey is a central theme of Maya religion. The sarcophagus lid is a statement about Pakal's death and his expected transformation into a divine ancestor. This interpretation is well supported by expert epigraphers and iconographers. The hieroglyphic texts on the lid and in the temple confirm that the image relates to death and descent. The symbolism matches patterns seen at other Maya sites, but there is another interpretation, one that has captivated millions of people and fueled decades of controversy. In 1968, the Swiss author Erich von Daniken published Chariots of the Gods, a book that would sell over 70 million copies and launch the ancient astronaut movement. Von Daniken's central claim was that extraterrestrial beings visited Earth in antiquity and influenced human civilizations. His evidence included various ancient monuments and artworks that he interpreted as depicting alien technology. The sarcophagus lid of Pakal was one of his star exhibits. Von Daniken looked at the image and saw something very different from Maya scholars. He saw a man operating a machine. The reclining figure, he argued, was sitting in a seat, hands manipulating controls, feet pressing pedals. The frame around him was the body of a spacecraft. Flames or exhaust emerged from the bottom. The figure was not dying, he was piloting. The interpretation was vivid, intuitive, and wildly popular. To modern eyes trained to recognize technology, the image does look like a person in a vehicle. The posture, the arrangement of elements, the sense of enclosure, all of it can suggest a cockpit. The idea spread rapidly. The astronaut interpretation appeared in documentaries, books, and eventually on the History Channel's Ancient Aliens program. Millions of people who have never read a Maya inscription believe that Pakal was an ancient astronaut, or at least that the Maya depicted space travel on his tomb. What should we make of this? Let us start with what we know for certain. The sarcophagus lid is a real artifact. It exists. It depicts something. The question is, what? Professional Mayanists reject the astronaut interpretation completely. Their objections are specific and detailed. First, the elements that von Daniken identified as technology are recognizable Maya symbols. The frame around the figure is not a spacecraft. It is the world tree, adorned with serpent heads, quetzal birds, and other standard Maya motifs. These elements appear throughout Maya art. They are not unique to Pakal's tomb. Second, the posture of the figure is consistent with Maya artistic conventions for depicting the dead or dying. The reclining position, the arrangement of limbs, the relationship to the underworld below, all of this follows patterns seen in other Maya monuments. Pakal is not operating controls, he is falling into death. Third, the hieroglyphic texts tell us explicitly what the image means. The inscriptions describe Pakal's death, his descent into the underworld, and his expected rebirth as a god. There is no mention of vehicles, space travel, or technology of any kind. Fourth, the skeletal jaw below the figure is clearly the Earth monster, a standard Maya symbol for the entrance to the underworld. The flames that von Daniken interpreted as rocket exhaust are stylized bones and death symbols. Fifth, the cross above the figure is the world tree with a celestial bird perched at its top. The world tree is one of the most important symbols in Maya cosmology. It appears on countless monuments and in the surviving Maya codices. The Mayanist interpretation is not speculation. It is based on decades of research, the decipherment of Maya hieroglyphics, the comparison of thousands of images across hundreds of sites, and a deep understanding of Maya religion and symbolism. From this perspective, the astronaut interpretation is not just wrong, it is embarrassingly wrong. It results from looking at Maya art with modern eyes and projecting modern meanings onto ancient symbols. Von Daniken and his followers counter that mainstream scholars are too closed-minded to consider alternative interpretations. They argue that the resemblance to a spacecraft is too striking to be coincidental. They suggest that the Maya may have depicted something they actually witnessed, something that conventional archaeology cannot explain. Who is right? The honest answer is that we cannot know with absolute certainty what was in the minds of the Maya artists who carved Pakal's sarcophagus lid. We can only work from evidence, and the evidence strongly supports the conventional interpretation. Every element of the image can be explained by reference to Maya symbolism. The interpretation is consistent with everything else we know about Maya religion. The hieroglyphic texts confirm the meaning. There is no need to invoke spacecraft or extraterrestrial visitors, but let us be fair to the alternative perspective. The astronaut interpretation is wrong, but it is not crazy. The image does have a technological appearance to modern eyes. If you have never studied Maya iconography, if you do not know what the world tree means, if you are unfamiliar with Maya conventions for depicting death and descent, the astronaut interpretation is understandable. The problem is that familiarity resolves the mystery. Once you learn Maya symbolism, the astronaut disappears. What seemed like technology reveals itself as religion. What seemed like a spacecraft is clearly a cosmic diagram. This is a recurring pattern in ancient astronaut claims. Unfamiliar imagery is interpreted as technology. Expertise dissolves the interpretation. The mystery was never in the artifact, it was in the observer's ignorance. Does this mean we should dismiss all ancient astronaut claims? Not necessarily. We should evaluate each claim on its evidence. We should be skeptical of interpretations that ignore expert knowledge. But we should also remain open to genuine mysteries. The question is whether there are genuine mysteries in Maya culture that conventional archaeology cannot explain. The sarcophagus lid is not one of them, but there may be others. Let us consider what we do not know about the Maya. We do not know why they chose the specific date of their long count starting point. August 11th, 3114 BCE corresponds to no known astronomical or historical event. Why that date? What happened, in Maya understanding, at the beginning of the current cosmic cycle? We do not know the full extent of Maya astronomical knowledge. The Dresden Codex preserves some calculations, but the Spanish destroyed the rest. What else did the Maya know? What observations and predictions have we lost forever? We do not know the origins of some Maya technologies. Maya blue, the brilliant pigment used in murals and on sacrificial victims, was not fully understood until modern chemists analysed it. The Maya created a nanostructured material, indigo bonded to palygorskite clay, that remained stable for centuries. How did they discover this? Trial and error seems inadequate for such a sophisticated result. We do not know the full meaning of Maya mythology. The Popol Vuh describes creation, destruction, and the activities of gods and heroes. How much of this is metaphor? How much is history? How much might encode real events that we cannot currently recognize? These are legitimate mysteries. They do not require ancient astronauts to explain them, but they do suggest that our understanding of Maya civilization is incomplete. There may be surprises yet to come. The fascination with ancient astronauts reflects something deeper than gullibility. It reflects a sense that the ancient world was more sophisticated than we often assume. It reflects a desire to connect human history to a larger cosmic story. It reflects dissatisfaction with explanations that seem to diminish the achievements of ancient peoples. The irony is that ancient astronaut theories actually diminish those achievements. By attributing Maya accomplishments to extraterrestrial help, the theories deny the Maya credit for what they genuinely accomplished. The Maya did not need aliens to build pyramids, develop astronomy, or create their calendar. They did it themselves. That is the true wonder. Pakal was not an astronaut. He was a king, a human being who ruled for 68 years, built monumental architecture, commissioned beautiful art, and died like all mortals die. His sarcophagus lid depicts his journey into death, not his departure in a spacecraft. The image is still remarkable. It is still beautiful. It still tells us something profound about how the Maya understood existence. Death was not an ending. It was a transformation. The king who descended into the underworld would rise again as a god. The world tree connected all realms. Time cycled eternally. That cosmology is worth understanding on its own terms. It does not need aliens to make it interesting. It does not need technology to make it meaningful. It is a human creation, made by human beings who thought deeply about life, death, and the structure of the cosmos. The astronaut interpretation will not go away. It is too visually compelling, too emotionally resonant, too embedded in popular culture. But it is wrong, and we should be clear about that even as we acknowledge the genuine mysteries that remain. Pakal sleeps beneath his pyramid. His jade mask stares into eternity. The world tree rises above him. The underworld opens below. He made the journey that all Maya kings expected to make. He became what the inscription said he would become. Not an astronaut, an ancestor, a god. The real mystery is not whether Pakal flew a spacecraft. The real mystery is how a civilization in the jungle, without metal tools or draft animals, created a culture of such sophistication and beauty. The Maya achieved extraordinary things. We should honor those achievements by trying to understand them accurately. The astronaut hypothesis is a distraction. The truth is more interesting. In the next chapter, we examine the calendar in detail, not the simplified version that appeared in 2012 apocalypse movies. The real calendar, the system of interlocking cycles that tracked time across millions of years. The calendar that counts forever. What did the Maya know about time, and what were they trying to tell us? Chapter 5. The calendar that counts forever. December 21st, 2012. The world did not end. For years, popular culture had been building toward this date. Books, movies, websites, and television programs warned of impending catastrophe. The Maya calendar, they claimed, predicted the end of time on this precise day. Doomsday scenarios range from asteroid impacts to magnetic pole reversals to the arrival of a mysterious planet called Nibiru. None of it happened. The sun rose, the day passed, life continued. The 2012 phenomenon was a spectacular misunderstanding. It took a sophisticated ancient calendar system, stripped it of context, and projected modern apocalyptic anxieties onto it. The Maya never predicted the end of the world. They predicted the end of a cycle. There is a difference. To understand what the Maya actually believed about time, we need to set aside the pop culture noise and examine their calendar, on its own terms,